Welcome back. In this video, we are given that z is the product of three complex numbers, and we want to find the norm of z. And we know that the norm of any complex number, z, that can be written as a plus ib, is the norm is the square root of z times z bar, with z bar being the conjugate of z. And if we do the algebra, we're going to see that this gives us a squared plus b squared. So therefore, to compute the norm of this one, we have to write z in this form. This is the algebraic form. That means we have to do the multiplication of these three complex numbers and find the norm. But hopefully there is another way to do that. Okay? So we're gonna prove the result that if we are given complex number z1, z2, zn, and we want to find the norm of the product. So the product of the norm is just the norm of the product is the product of the norms. Okay, and here, so to compute the product of z, we're going to compute the norm of this one times the norm of this one times the norm of this one. And therefore, we will make it easier. We prove this result for the case n equal 2, and we can do that by induction for any n. Okay? In fact, for two numbers, z1, z2, we have the norm squared. By definition is z1, z2 times z1, z2, the conjugate of z1, z2. But we know that the conjugate of the two numbers is the product of the conjugates. Therefore, we have z1 times z2 times z1 bar times z2 bar. And we know that the product is commutative, so we can take this one here. We have z1 times z1 z1 bar, times z2 times z2 bar. And what's this one here? By definition here, so this is just z1 squared. And this one just z2 squared. These numbers are all positive. Therefore, we take this, the square root, and we get the norm of z1, z2 is just z1 times z2. Remember that the norm of a complex number is real. So z is real. So it's a real number. Okay, therefore we can use this result here for z1, z2, z3, and this means that our norm here becomes the norm of this one here, minus 1 plus I, times the norm of minus 3 plus I times minus 5 plus I. First, we're going to apply the norm to all of them, and after that, we're going to apply the norm to each one. So the norm of minus 1 plus I times the norm of minus 3 plus I times the norm of minus 5 plus I. And the norm of this one is just the square root of the real part squared plus the imaginary part squared. This one is coming from the one here. 1 times I is I, times the square root of minus 3 squared plus 1 squared times minus 5 squared plus 1 squared. Therefore, here we have square root of 2, here we have square root of 10, and here we have the square root of 26. We can simplify one more by taking a square root from the 10. So we have square root of 2 times square root of 2 times square root of 5 times square root of 26. So here we get 2 square root of 5 times 26, which is 130. So here 2 square root of 130. And this is a real number. Therefore, the norm of z is 2 square root of 3. Remember, the key idea here is the definition of the norm, and that the norm of the product is the product of the norms. Thank you very much.